Hello. How many asymptotes does the following rational function have? Take a minute to try this problem for yourself, otherwise I'm going to show you how I solved it. We're going to start out by factoring the numerator and the denominator. Cubics can look very intimidating to factor, but in this case factoring by grouping works very well. So we're going to factor the first two terms and the last two terms separately. So x cubed plus 3x squared, we can remove an x squared term, and that leaves us with x plus 3. And then negative 4x minus 12, we can remove a 4. So we get minus 4 times x plus 3. And since x plus 3 is a common factor with both terms, we can factor it further. But we're going to save that until after we factor the denominator. So same deal, we're going to pull an x squared term from x cubed minus 2x squared, leaving us with x minus 2. And from negative 9x plus 18, we could remove either, but you're going to see that if we remove a negative 9, it just works better. So negative 9 times x minus 2. And that again gives us a common factor. So now we can rewrite the numerator as x squared minus 4 multiplied by x plus 3. And the denominator as x squared minus 9 times x minus 2. And currently we can't really see any common factors yet, but both the numerator and the denominator have a difference between squares, meaning that we can factor that further. So we're going to rewrite x squared minus 4 as x minus 2 times x plus 2, and that is of course multiplied by x plus 3 still. And then we can factor x squared minus 9 into x minus 3 times x plus 3, and there's still that x minus 2 term. So now there are common factors between the numerator and the denominator. There always were, but now we can actually see them. So the x plus 3's now cancel, as well as the x minus 2's, meaning that f of x can be rewritten as x plus 2 over x minus 3. But it is important to note that f of x is not defined at x equals negative 3 or 2. However, the only asymptote expressed by f of x is at x equals 3. And just to prove that this is true, I'm going to plot this function and this function into Desmos, so you can both see the asymptote and that they're the same function. So this is f, and as you can see, there's only one asymptote. And as you can see, it expresses one asymptote at x equals 3. Additionally, it has holes at x equals negative 3 and x equals 2. Now let's write the other function that we simplified it down to, x plus 2 over x minus 3. And you can see they overlap. I hope you enjoyed today's problem. If you used a different method of finding the solution, let me know what it was in the comments below. Bye.